This is a problem from your lab assignment, section 3.7, problem number 1. It says here that we have a tank that holds 6,000 gallons of water, which drains in the bottom of the tank in 50 minutes. Torricelli's law gives us the volume of the water remaining in the tank after t minutes by this function. V of t is equal to 6,000 times 1 minus 1 over 50 times t to the second power. And these are good values for t going from 0 to 50 minutes, because before 0 times 0 there's nothing, and after 50 minutes then the whole thing would have been empty. It says find the rate at which the water is draining from the tank after the following amount of time. So remember, the rate must be negative because the amount is decreasing. So the rate at which the volume changes is going to be given by the derivative of v, so that's v prime of t. And so what we need to do is we need to take the derivative of this. So off to the side, you would probably want to do this on a piece of paper. We're going to take the derivative of this function v. And initially, when I do this derivative, I would take this power down. And so I would put the power down here, so it's going to be 2 times 6,000. And then I'm going to say this is going to be this to the first power, and then I want the derivative. The chain rule tells me that I need to take the derivative of the inside. So over here, I need to take the derivative of the inside, and the inside I'm going to have a negative 1 over 50. So I probably want to put that in parentheses so it doesn't look like I'm subtracting. And this is my my derivative function. So I can put that there. I probably should simplify it a little bit. Just to be sure, I want to use my calculator. So I have 2 times 6,000, and then I'm going to divide by 50. So I'm going to have a factor of 240, and remember that that's going to be a negative, so that's going to be my solution, 240, and that is going to be multiplied by 1 minus 1 over 50 times t. Let's make sure that the t is in not in the denominator, and it's to the first power, so we can just close the parentheses, and I think we're good. And so that should be the derivative. Therefore, when t is equal to 5, the rate at which the water is draining, so we want to find the rate of change, and I basically want to put 5 in for t in here. Let's see, we probably should use a calculator for this. I have 1 minus 1 over 50 times 5, so I'll start with 5 divided by 50. And then I'm going to subtract 1 from it, so I need this to be a minus, and then I'll add 1. And that's a 0.9 to the first power, and then I'm going to multiply this by negative 240. So I'm using a scientific calculator. If you have a graphing calculator, that might be a little bit easier because you can just follow through the steps going from left to right instead of going from inside to outside. All right, we got negative 216. So that's good so far. So that's the first part. The second part, as we found earlier, the rate is going to be equal to this v prime of t is equal to negative 240 times 1 minus 1 over 50 t. When t is equal to 10, the rate at which the water drains, therefore, is equal to, so we're going to go through the same process, except we're going to put 10 in there. 10 divided by 50, and then subtract it from 1. So we got a 0.8, and then we're going to multiply this by 240 negative, and then you get negative 192. And the next part, we have that rate, and now we're going to put 50. We're going to put 20 in there, sorry. So let's put 20. Again, 20 divided by 50. And then adding 1 to the negative of that. And then multiplying by 240 negative. Now, if you have a graphing calculator, you can probably do this a little bit easier. And as a matter of fact, since we're just using a bunch of formulas here, you could probably use Excel as well. You have one formula and you're putting in the same values. So 50 minutes. So this will be towards the end. Now this thing goes all the way to 50, so this is going to be at the end of that. So this is going to be, oh, I think they forgot to put a negative sign in front of this 240. But if you put 50 here, this is 1 minus 50 over 50. But 50 over 50 is 1, so I think that's going to end up to be a 0 anyways. So as you can see, it kind of looks like it starts off with a high rate of gallons per minute going down, and it starts to decrease in a negative direction, getting less and less negative, and then until it comes to 0 here. All right, so the last question, found earlier that this thing drains when t is equal to 50 is equal to 0. At what time is the water flowing the fastest, and at what time is water flowing the slowest? So the fastest is at the beginning when t is equal to 0. And then it starts to slow down, and then when it's finally empty, all the way at the end, that's when it's flowing the slowest. So that's going to be our answer. Okay, so that's it, and I hope that helps.